Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 3 Laws of Motion. We were discussing the topic gravitation. Today, we will be discussing free fall and mass and weight. Also, we will be solving questions from exercise 3E. Are you ready for the session? Let's begin. You can see that when I release the ball, I am not applying any force till it falls to the ground. Is there any force acting on it? Yes, there is force of gravity. Due to force of gravity, the ball falls down. Yes, so here you can see that there is no other force acting on it and hence we can say that the body is under free fall. Okay, you can see the apple falling. Okay, apple was on a apple tree due to force of gravity. The earth attracts the apple and it falls to the ground. Okay, so we can say that when a body is allowed to fall from a certain height, it falls to the earth due to the force of gravity. Okay, so now when the ball is released, you know that it comes to the ground. Here you can see what happens to the velocity. It is getting displaced. Okay, due to the rate of change of displacement we call velocity. There will be velocity. Here what happens to velocity? Initial velocity will be 0. Final velocity will have a value, that is velocity is increasing. Velocity increases. Okay, and we have said that this force, due to this force, there is an acceleration and this acceleration will be a constant value. This is an example of uniformly accelerated motion, that is velocity increases at a uniform rate. This is a uniformly accelerated motion and the acceleration here will be positive g meter per second square. What is g? G we have studied, which is acceleration due to gravity whose value is 9.8 meter per second square plus 9.8 meter per second square. This positive side is because the body is moving in the same direction as the direction in which the force is acting. Force is downwards and the body is also moving downwards. Clear? So here acceleration A will be positive g. Now, when I throw the ball up, you can see that the ball will initially reach a point and then fall to the ground. To throw the ball up, I have to apply a force. Okay, when I just release, it will fall to the ground. So, if it should move up, I have to apply a force. I am applying a force. Okay, there will be some velocity, that is the body will be gaining some velocity. Now, what happens is, when it reaches the highest point, its velocity will become equal to 0. So, here you can see upward motion, right? In which direction gravity will be acting? The force of gravity will always be in the downward direction. So, once the velocity becomes 0, what happens? The ball will fall to the ground because of the force of gravity. Okay. Now, you can see during the upward motion, the body is moving in the upward direction and the force of gravity is in the opposite direction. Therefore, in this case, acceleration will be equal to minus g meter per second square. Okay. Minus 9.8 meter per second square is the acceleration in this case when the body is moving in a direction opposite to the direction in which the force is acting. And the first case, the body is moving in the same direction as the direction in which the force is acting. Clear? Equations of motion. In the previous chapter, we have discussed 3 equations of motion. So here, when a body is under free fall, what are the changes to these equations of motion? We are going to get 3 new sets of equations. Okay. So what are the 3 equations of motion? First equation of motion, V is equal to U plus AT. Second, S is equal to UT plus half AT square. Third equation, V square is equal to U square plus 2AS. Equation 1, equation 2, equation 3. Newton's 3 equations. Now, here you can see when a body is just released, you are not applying any force, which means the initial velocity of the body will be 0. Okay. U is equal to 0. So, we are considering if a body falls from rest freely from a height h under gravity. So here the height will be the total displacement. So when you are releasing a ball, the total displacement or the total distance travel will be the height. Yes. So S will be equal to h. Okay. What about acceleration? Here no other force is acting. The only force acting is the force of gravity. Therefore, acceleration will be positive g. Here the body is moving in the same direction in which the force is acting. Okay. Now, in these equations, we are going to replace, in place of u, you will be putting 0. In place of s, you will put h. And in place of a, we will be putting positive g. So, here you can see, here we have u, u, u. All these I am going to replace with 0. A with G, and here you have an S and here you have an S, which we will be replacing with H. Okay. So, what is the first equation then? V is equal to 0 plus GT, which is V is equal to 0 you can omit. So, then you will be having GT. V is equal to GT. V is the final velocity. G is the acceleration due to gravity. T is the time. Second equation, S is equal to, becomes H is equal to UT, 0 into T plus half G T square. So, H is equal to half G T square. This is the second equation. Now, the third equation, V square is equal to 0 square plus 2GH. Okay, replacing A with G and S with H. Then what is V square? V square will be equal to 2GH. This is the third equation. So, we got 3 new equations. These equations are when the body is under free fall. There is no force other than gravity acting on it. It is moving the same direction in which the force is acting. Clear? Next case is when initial velocity of fall of the body is u. We have the 3 equations. V is equal to u plus at, S is equal to ut plus half at square, and V square is equal to u square plus 2as. So, here what are the things that we have to change? Now, the body has an initial velocity. We are applying a force. Body is moving in the same direction as the direction in which the force is acting. Okay. Therefore, A will be equal to positive G. Then, S will become H. Only these 2 changes, because here U will have a value, which we will be putting as U itself. Okay. So, what is the first equation then? V is equal to U plus GT. In place of A, I have replaced with G. This is the first equation. Second equation, S becomes H. H is equal to UT plus half GT square. This is the second equation. And what about the third equation? V square is equal to U square plus 2as. V square is equal to U square plus 2GH. So, what is the difference? In the previous set of equations, we didn't have U. There we had 0, but here we have U. So, in these set of equations, if you put U is equal to 0, you will be getting the other equation. Clear? So, here a force is applied. Okay, there is a force other than gravity. Only in that case, U will have a value. Otherwise, U will be 0. Next case, if a body is thrown vertically up with an initial velocity U to a height h. So, I am applying a force and throwing the ball up. What is happening? It is moving in the upward direction. This is the direction in which the ball is moving and the force of gravity is acting downwards. Okay. It reaches a height, let's say h. Okay. So, during this upward motion, what will be the acceleration? Acceleration will be minus g. Acceleration due to gravity with the negative side. Why is this negative side? Because the motion of the body is in a direction opposite to the direction in which the force of gravity is acting. Okay. Then what are the equations of motion? V is equal to u plus at. Changes into V is equal to, we are applying a force, therefore there is an initial velocity u minus gt. Okay. In place of A, we will be giving minus g. Plus minus g becomes minus g. Okay. So, this is the first equation. Second equation, S is equal to ut plus half a t square. This becomes, S is the total displacement, which is h, is equal to ut plus half minus g t square, or h is equal to ut minus half g t square. There is a negative sign. Okay, so this is the second equation. Now the third equation, we have v square is equal to u square plus 2as, which changes into v square is equal to u square plus 2 into minus g into h. That is v square is equal to u square minus 2gh. This is the third equation. So first equation, v is equal to u minus gt. Second equation, h is equal to ut minus half gt square. Third equation, v square is equal to u square minus 2gh. Okay, so here a force is applied. Due to the force, there is an initial velocity and the body is moving in a direction opposite to the direction in which the force of gravity is acting. Now we have these three equations for a body that is thrown upwards. Okay, now let's see what is the maximum height reached by the ball. Okay, so when a ball is thrown upward, we can see that at a maximum height, it will reach a maximum height where the velocity will become 0. Yes, when the velocity becomes 0, after that what happens? The ball will fall down. Okay, it will come to the ground since velocity becomes 0. So when velocity is equal to 0, the body is at its maximum height. Okay, now let's find what this maximum height is, h max. Okay, so here when velocity becomes 0, take the third equation. We have v square is equal to u square minus 2gh. Okay, in this case, v becomes 0. 0 is equal to u square minus 2g maximum height, h max. Okay, this will be equal to u square is equal to 2g h max. The negative sign becomes positive and taken to the opposite side. Then what is h max? H max will be equal to u square divided by 2g. If you know the initial velocity and we know the g value, which is 9.8 meter per second square, we can calculate the maximum height. Now what is the time taken to reach that height? To find that time, take the first equation. V is equal to u minus gt. Okay, v becomes 0 at the maximum height. Okay, 0 is equal to u minus gt, which means gt is equal to u and t is equal to u divided by g. Okay, so from here to here, the ball reaches the maximum height. H max is equal to u square by 2g, and the time taken for this t is equal to u by g. Okay, now from this position to reach the initial positions, okay, what is the time taken? Time taken will be the same. Yes, from here to here, how much time it takes? The same time will be from here to here, which means from its initial point to the same point, for the ball to reach, the total time taken, what will be the total time? Total time will be equal to u by g plus u by g. Okay, u by g is the time taken to reach here and u by g again is the time taken to reach here. So total time will be u by g plus u by g, which is 2u divided by g. Okay, so the total distance to reach the initial point, okay, from here it has started. So total distance travelled from here to here, it is u square by 2g. Again from here to here, it is u square by 2g. Then what is the total distance? Total distance will be equal to u square by 2g plus u square by 2g. That is equal to 2 into u square by 2g, which is equal to u square by g. 2 and 2 gets cancelled. Okay, so total time is 2u divided by g, and the total distance to reach the same point will be equal to u square by g. So when you throw a ball and place your hand here, the ball goes up, reaches the maximum height at velocity is equal to 0. It comes back to your hand. The total time taken will be 2u by g, and the total distance travel will be u square by g. Okay. Next, we are going to discuss about mass. What is mass? Here we have a boy whose mass, let's say, is 30 kilogram. We have studied about mass, and the unit of mass is kilogram. The SI unit is kilogram, other units, gram, tons, etc. are other units. So the boy's mass is 30 kilogram. We are measuring it on the surface of Earth. When measured on the surface of Earth, we got mass of the boy on Earth is 30 kilogram. Then he is taken to the Mars and his mass is measured. On measuring, we got the boy's mass on Mars is also equal to 30 kilogram. Now, when the boy is taken to Moon and his mass is measured, we got mass of the boy on Moon is also equal to 30 kilogram. What do you understand from this? Mass is constant. In whichever planet we are doing the measurement, the mass will be a constant value. Whether you take the case of Earth, whether the boy is at the equator or at the poles or the center of Earth, his mass will be the same, which is 30 kilogram. Now we can define mass. The mass of a body is the quantity of matter it contains, or it is the amount of matter contained in a substance. Okay, what is the unit? Its unit is kilogram, and it is a scalar quantity. What are scalar quantities? Quantities which has only magnitude and no direction. Okay, 30 kilogram. 30 kilogram. Okay, whether this 30 kilogram body is moving to right, to left, it doesn't matter. It is only dependent on the magnitude. So it is a scalar quantity. SI unit is kilogram. What are the other units? There are grams, milligrams, etc. Okay. Next, it is a constant for a given body at rest. If the body is not moving, it will be a constant value. So we have said on the surface of Earth, on the surface of Moon, or on the surface of Mars, it will be having a same value. Okay. Now, if it is moving, let's say if the velocity of the body is less than the velocity of light, then the body's mass is not going to change. But the mass increases with increase in velocity only when the velocity of the body is greater than or approximately equal to 3 into 10 raised to 8 meter per second, which is the speed of light in air. Okay, only when this velocity, the body's velocity increase beyond this value, only in that case the mass will increase. Until then, the mass will be a constant value. Clear? Now, it is an intrinsic property of a body. That is, it does not depend upon the amount of matter that is taken for measurement. It is an intrinsic property, or it is an inherent property of a material. Clear? Now, it is measured by a physical balance or beam balance. This is how a physical balance or beam balance look like. You know this thing. Okay. So, this material is used in order to make a measurement of mass. Next, the mass of a body increases with velocity, which we have already said. When does it increase? Only when the velocity is greater than the speed of light. Okay, so these are the important points you need to remember about mass. We had measured the boy's mass on Earth, Mars and Moon. Okay, mass was the same, which is 30 kilogram. Now, when the weight was measured, for the boy's weight was measured on the surface of Moon, surface of Earth and surface of Mars, we got different values. On the surface of Earth, it was 294 Newton. On Mars, when the measurement was made, it was 120 Newton. And when the measurement was made on Moon, we got 48 Newton. You can see different values, which means the weight of a body, weight of any object will be different on different planets. Now, when you take the surface of Earth, when you are at equator, at poles or the center of Earth, there will be getting different values of weight, which means the weight will be different depending on the place. where the object is. But the mass will always be a constant value. We know Earth attracts every object towards its center. The force with which Earth attracts every object is the weight of the object. If I am attracted to Earth, that is Earth attracts me with the force which is my weight. Okay, and this weight will always be acting in the downward direction, okay, to the center of Earth. Now we can define weight. The weight of a body is the force with which the Earth attracts it. Okay, we know that mass is a scalar quantity, but weight, it is a vector quantity. And weight of a body is the force of gravity. How much force of gravity is acting on it will be the weight of the object. Its direction is towards the center of Earth. It is depending on the direction. What are vector quantities? Vector quantities has both magnitude and direction. When you take the case of mass, there is only magnitude, but here direction is important. Direction is downwards. Therefore, it is a vector quantity. Weight is a vector quantity. Clear? Now, unit of weight, the SI unit of weight is Newton. Okay, Newton, it is a force. We have said weight is a force. It is a force of gravity acting on a body. The SI unit is Newton and the CGS unit is dyne. There is a relation between this Newton and dyne. 1 Newton will be equal to 10 raised to 5 dyne. Okay, relationship between mass and weight. So, when you stand on a weighing machine, is it actually a mass or the weight? We say my weight is 60 kilogram or 50 kilogram. What does it mean? We are measuring it in kilogram. Yes, we have studied that the unit of weight is Newton. So, here we don't say 60 Newton or 50 Newton. Why is it? We have said in the first example, mass of the boy was 30 kilogram. When measured on Earth, we got the weight to be equal to 294 Newton. What has happened here? Here what happens is the weight is calculated. Weight will be equal to mass into acceleration due to gravity. W is equal to m into g. Okay. We know when you make a measurement on the surface of Earth, what will be the value of g? G will be equal to 9.8 meter per second square. So, in this example, we got the weight which is 30 kilogram mass into 9.8 meter per second square acceleration due to gravity. Then you are getting this 294 Newton value. Okay, so this weighing machines are designed in such a way that when you actually measure, it is not your weight but the mass. That value we get is the mass of the body. So, when you stand on a weighing machine, the force of gravity is acting downward. You will be getting the actual weight, okay, from which it is designed in such a way to show your mass. So, actually 60 kilogram or 65 kilogram, it is your mass and not the weight. The weight will be if it is 60 kilogram. Okay, if your mass is 60 kilogram, the weight will be 60 kilogram into 9.8 meter per second square. So, to do the calculation, to make the calculation more easier, you can take 10 meter per second square. In some questions, it will be given to take the acceleration due to gravity 10 meter per second square. Okay, or you can just calculate this 9.8 into 60. When you do the calculation, you will be getting 588 Newton. Okay, and the weight will be 588 Newton, not 60 kilogram. Okay, when the measurement is made on mass. Okay, if the measurement is made on mass, what happens? We had got 30 kilogram was the boy's mass. Okay, we got the weight to be equal to 120 Newton. We don't know what the acceleration due to gravity on Mars is. So, we can find the acceleration due to gravity on Mars. G on Mars will be equal to 120 Newton divided by 30 kilogram. Just approximate value we can take, which is equal to 4 meter per second square. Okay. If you need to find on the moon. On moon, we got 48 Newton is the weight, 30 kilogram mass. G on moon can be determined. Clear? So this is the relation between weight, mass and acceleration due to gravity. Weight is equal to mass into acceleration due to gravity. If weight and acceleration due to gravity is given, we can find the mass. Mass will be equal to weight divided by acceleration due to gravity. Okay, now you have to find the acceleration due to gravity or any planet. If the weight and mass is given, weight divided by mass, you will be getting the acceleration due to gravity on that particular planet. So now we have the relation between weight and mass. Weight is equal to mass into acceleration due to gravity. The unit of mass is kilogram and the unit of acceleration due to gravity is meter per second square. Kilogram meter per second square. Weight is kilogram meter per second square. So the acceleration due to gravity, one unit is meter per second square. There is another unit for acceleration due to gravity. We will be having G is equal to weight divided by mass. Unit of weight we have Newton and the unit of mass is kilogram. Okay. Therefore, the second unit of acceleration due to gravity is Newton per kilogram. Now let's see how we are obtaining this relation. 1 Newton is equal to 10 raised to 5 dyne. Okay. So we have weight is equal to kilogram meter per second square. Okay. Now we have to convert it into the CGS. CGS means first we have to convert the meters into centimeters. To convert meters into centimeters, we know that 1 meter is equal to 100 centimeters and convert the kilogram to gram. 1 kilogram is equal to 1000 grams. So this becomes 1000 grams into 100 centimeter per second square. So which is equal to 1, 2, 3, 4, 5. 10 raised to 5 gram centimeter per second square is 1 Newton. If the weight is 1 Newton. Okay. So 10 raised to 5 gram centimeter per second square is dyne. Okay. So this becomes 10 raised to 5 dyne. So this is how it is obtained. Clear? This is how 1 Newton becomes 10 raised to 5 dyne. We know that the mass of a body will be the same at every places. But we know acceleration due to gravity will be different. So depending on the acceleration due to gravity, weight also will be different. Weight will be different on different planet. Weight will be different at the equator. Weight will be different on the poles. At the center of earth, weight will be different. Okay. We know that weight is equal to mass into acceleration due to gravity. Now we have a relation 1 Newton is equal to 10 raised to 5 dyne. In the MKS unit or in the MKS system, the weight will be measured in another unit which is kilogram force, kgf. Okay. So 1 kilogram force will be equal to 9.8 Newton. Okay. We know that 1 Newton is equal to 10 raised to 5 dyne, which means 1 kilogram force will be equal to 9.8 into 10 raised to 5 dyne. If we need 1 gram force, 1 kilogram is 1000 grams. 1000 gram force will be equal to 9.8 into 10 raised to 5 dyne. Okay, which means 1 gram force will be equal to 9.8 into 10 raised to 5 divided by 10 raised to 3 dyne, that is equal to 9.8 into 10 raised to 2 dyne or 980 dyne. Okay, 1 gram force will be equal to 980 dyne. So if you have a body of mass m kilogram, its weight will be, in the MK system, the weight will be m kilogram force. So if you are using a spring balance, you will be getting the weight in newtons, and if you are using a physical balance, then you will be getting the weight in kilogram force. Understood? Weight of an object on moon. We have studied that the weight of an object on earth is the force with which the earth attracts the object. Okay. Then what is weight of an object on moon? Weight of an object on moon is the force with which the moon attracts the object. Okay. So here the mass of earth, radius of earth, mass of moon and radius of moon are given. Now how to find the weight? We know weight is a force and the unit of weight is Newton. We have the universal law of gravitation. Force is equal to G m1 m2 divided by r square. So when you are going to find the mass of an object, to find the weight of an object on moon, Wm, it will be equal to universal gravitational constant g. First mass will be the mass of moon. And the second will be the mass of the object on moon. Okay. Mass of the object will be same on moon, whether it is on moon or whether it is on earth. And then the separation, that is r square. Okay. Here it will be the radius of moon square. Okay. Now, weight on earth will be the universal gravitational constant into mass of earth me, mass of the object m, divided by re square, where re is the radius of earth. Okay, now we are going to find a relation between weight of an object on moon to the weight of an object on earth. So taking the ratio Wm by We, we get Gmm into m divided by Rm square divided by Gme into m divided by Re square. Okay, this is equal to Gmm into m divided by Rm square into, taking the reciprocal of this and then multiplying Re square divided by Gme m. Okay, so G gets cancelled, m gets cancelled, then you will be having mass of moon by radius of moon square into radius of earth square divided by mass of earth. Okay, next putting the values, Wm by We is equal to mass of moon. Mass of moon is 7.36 into 10 raised to 22 divided by radius of moon square, that is 1.74 into 10 raised to 6 whole square into radius of earth is 6.37 into 10 raised to 6 whole square divided by mass of earth 5.98 into 10 raised to 24. Okay. So when you calculate this, you will get approximately 1 by 6, which means the ratio of weight of an object on moon divided by weight of an object on earth will be equal to 1 by 6, or weight of an object on moon will be equal to 1 by 6 times weight of the same object on earth. So, if we have an object of weight 60 newtons on earth, then what is its mass? What is its weight on moon? Weight on moon will be equal to 1 by 6 times 60 newton, which will be equal to 10 newtons. Weight on moon will be equal to 10 newton. So, this is the relation between weight of an object on moon and the weight of an object on earth. Okay. So, which is less? Weight of this object on moon will be less than the weight of object on earth. It is the weight of the object on moon will be 1 by 6 times the weight of the object on earth. Next, we'll make a comparison between mass and weight. So, first point, it is a measure of the quantity of matter contained in the body, and weight, it is the force. Okay, so mass is not a force, but weight is a force with which the earth attracts a body. This is a simple definition of mass and weight. So in the comparison, you can write the first point. Okay, second point, it is a scalar quantity and weight is a vector quantity. Third, SI unit of mass is kilogram and that of weight is Newton. We have discussed other units as well. Now the fourth point is measured by a physical balance or a beam balance is used to measure. So it is measured by a spring balance. In this case, spring balance is used, which is calibrated to do it in Newton. So spring balance will give you the result in Newton. If you are using a physical balance, then you will be getting weight in kilogram force. Next point, it is constant for a body and does not change with the change in place. What about weight? It is not a constant for a body but varies from place to place due to change in the value of g, because weight is equal to mass, which is a constant, into acceleration due to gravity. The value of g can vary, therefore the weight can also vary. W is equal to m into g. Gravitational units of force. In the MKS system, the gravitation unit of force is kilogram force. So what is 1 kilogram force? 1 kilogram force is the force due to gravity on a mass of 1 kilogram. This is equal to 1 kilogram into acceleration due to gravity g meter per second square. That is equal to g kilogram meter per second square or g Newton. So 1 kilogram force is equal to g Newton. We know the value of g. So 1 kilogram force is equal to 9.8 Newton. Which means 1 Newton will be equal to 1 divided by 9.8 kilogram force. So, for an approximation, we can take 1 kilogram force, G value as 10. Okay, if G value is approximated to 10 meter per second square, then we will be getting 1 kilogram force is equal to 10 Newton, which means 1 Newton is equal to 1 by 10 kilogram force, which is 0.1 kilogram force. Okay, and now in the CGS system, the gravitational unit of force is gram force. So then what is 1 gram force? It will be mass 1 gram into acceleration due to gravity g in centimeter per second square. Okay, so here you have to remember G value. What will be G value now? G value, we know that it is 9.8 meter per second square. So if you are taking in centimeters, then what will be the G value? So to convert into centimeters, we have to multiply with 100. So G should also be multiplied with 100. So G into 100 should be there. Okay. So 1 gram force will be equal to 1 gram into 9.8 into 100 centimeter per second square, that is equal to 980 gram centimeter per second square. So 1 gram force is equal to 980 gram centimeter per second square is dyne. Okay, so these are the two units. One is kilogram force and the other is gram force. We know the conversion also. Yes, so we are getting 1 kilogram force is equal to 9.8 Newton. So here we have 980 dyne. Okay, so what is 1 dyne? We have 1 Newton is equal to 10 raised to 5 dyne. Okay, so here we have 980 dyne. Okay, then how do you get it in Newton? We'll be having 1 dyne is equal to 10 raised to minus 5 newtons. Okay, so converting, we get 1 GF is equal to 980 into 10 raised to 5 minus 5 Newton, that is equal to 9.8 into 10 raised to minus 3 Newton. Okay, so we have the relations. So here we have 1 gram force, 1 kilogram force is equal to 9.8 Newton. And now we have 1 gram force, that is equal to 9.8 into 10 raised to minus 3 Newton. Okay, now dividing. What do we get? 1 kilogram force. 1 kilogram force will be equal to 9.8. 9.8 gets cancelled. 10 raised to 3 can be taken to the numerator. Now when I take this 1 gram force to the opposite side, becomes into 1 gram force, which means 1 kilogram force will be equal to 1000 gram force. So this is the relation between kilogram force and gram force. Clear? Let us take an example. A body of mass 10 kilogram is taken from the earth to the moon. If the value of G on earth is 9.8 meter per second square and on moon is 1.6 meter per second square. First question, find the weight of the body on earth. And the second question, the mass and weight of the body on moon. How to find the weight on earth? We are given mass M. Mass will be same whether it is on earth or moon. Mass is given, that is 10 kilogram. Acceleration due to gravity on earth is equal to 9.8 meter per second square. Then what is the weight on earth? Weight on earth will be mass into acceleration due to gravity on earth. That is 10 into 9.8 equal to 98 Newton. So weight on earth is equal to 98 Newton. Okay. Now the second part of the question, we have to find the mass and weight of the body on moon. Mass on moon will be same as the object's mass on earth, that is 10 kilogram. Now to find the weight on moon will be equal to mass into acceleration due to gravity on moon. Acceleration due to gravity on moon is given, which is 1.6 meter per second square. So weight on moon will be equal to 10 into 1.6, that is 16 Newton. Weight on moon is 16 Newton. Clear? Second example, a stone at rest is dropped from a height and falls freely under gravity. Calculate the distance covered by it in the first 2 seconds. G is equal to 9.8 meter per second square. So here we have a stone which is at rest and it is released. It is freely falling to the ground. Total distance covered is h, the height h. Okay. Now time taken is given. T is equal to 2 seconds. Okay. Here we have the equations. V is equal to U plus GT. Then H is equal to UT plus half GT square. And V square is equal to U square plus 2GH. Which one can we use? What are the given quantities? In this question, we are given U is equal to 0. Why? Because the body is initially at rest. Time is given. T is equal to 2 seconds and G value is 9.8 meter per second square. So, which equation to use? If we are using the first equation, we cannot find the total distance covered because here we don't have the h. Okay. So, either of these two equations we can consider. So, here we have h is equal to ut plus half gt square. U we know, u is equal to 0, t is 2 and g is 9.8 meter per second square. So, this can be used. Okay. To use this, we cannot use this because we don't know the final velocity. Okay. So, taking this equation, h is equal to ut plus half g t square. Substituting the values. 0 into 2 plus half 9.8 2 square. That is equal to 0 plus half into 9.8 into 2 into 2. Which is equal to 2 gets cancelled. 9.8 into 2 is 19.6 meters. So, the distance covered will be equal to, distance covered is equal to 19.6 meters. Okay, for the stone to reach the ground, it takes 2 seconds and the total height or the total distance covered will be equal to 19.6 meters. Third example, a body is dropped freely under gravity from the top of a tower of height 78.4 meters. So, here there is a body at the top of the tower. It is dropped to the ground. The total height is 78.4 meters. Okay. So, we have to calculate the time to reach the ground and the velocity with which it strikes the ground. Take G is equal to 9.8 meter per second square. So, here we have 3 equations. V is equal to U plus GT. H is equal to UT plus half GT square. And the third V square is equal to U square plus 2GH. Here what are the given quantities? We have U is equal to 0. Why? Because a body is dropped freely under gravity. There is no other force except gravitational force. So, U will be equal to 0. Then, G is given 9.8 meter per second square. Okay. H is given, which is 78.4 meters. So, the first part of the question, we have to find the time to reach the ground. So, here you can see either using the first equation or second equation, we can find the time. Because in the third equation, there is no t value. Okay. Now, take these two equations. In this first equation, only if the final velocity is known, we can find the value of t. Why? Because there should be only one unknown quantity. So this cannot be used to find the time. Okay, so you will be using the second equation, that is h is equal to ut plus half g t square. Now put the values. H 78.4 is equal to 0 into t plus half into 9.8 into t square. Okay. So this becomes 0. 78.4 is equal to 0 plus 9.8 by 2 is 4.9 t square, which means t square will be equal to 78.4 divided by 4.9, which is 784 divided by 49 equal to 16. T square is 16. Then what is t? T will be equal to root 16. Root 16, two values are possible, positive 4 and negative 4. Time cannot be negative, so only possible value is positive 4. 4 seconds is the time. Okay. Now the second part of the question. The velocity with which it strikes the ground, which means we have to find the final velocity. So when you take the equation, first equation, V is equal to U plus GT. Check whether we have all the values. We know the value of U, we know G, we also know what is T. Okay. Now put the values. V will be equal to 0 plus 9.8 into 4. Okay. That is equal to 39.2 meter per second. Okay. So the final velocity or the velocity with which the body strikes the ground will be equal to 39.2 meter per second. Okay. So V is equal to 39.2 meter per second. Understood? Example 4, a ball is thrown vertically upwards. It goes to a height 19.6 meter and then comes back to the ground. Find the initial velocity of the ball, the total time of journey, the final velocity of the ball when it strikes the ground. Take G is equal to 9.8 meter per second square. So a boy is standing on the ground and throwing a ball. It reaches the maximum height and comes back to the ground. Okay, so what are the given quantities? We are given it goes to a height of 19.6 meter, which means this height is h is equal to 19.6 meter. Okay, we don't know what the initial velocity is. First, we have to find the initial velocity of the ball. So, take this part of the journey. The ball is thrown upwards. It reaches the maximum height. Okay. At maximum height, we know velocity will become equal to 0. Final velocity is 0. So, using this, we can find what is the value of initial velocity u. So, to get this, we have the equation v square is equal to u square plus 2gh. So, here you have to remember g will be negative. What is the reason? The body is moving in a direction opposite to the direction in which the force is acting. Yes. So, g will be minus g. V square is equal to u square minus 2gh. So, we are asked to find the initial velocity. Okay. What is v square? V will become equal to 0. 0 is equal to u square minus 2gh. U square is equal to 2gh or u is equal to root of 2gh, which is equal to root 2 into 9.8 into height. What is the height? Height is 19.6. So, this is equal to root of 2 into 9.8 is 19.6 into 19.6. That is equal to root of 19.6 whole square, which is 19.6 meter per second. Okay. So, u is equal to 19.6 meter per second. Now, the second part of the question, we have to find the total time of journey. Total time of journey is the time taken to reach from this point to this point plus the time taken to reach from this point to this point. Okay, upward motion and the downward motion both should be considered. Okay, now how to find the time? Which equation to use? We have V is equal to U minus GT. Why minus sign is used? Because the body is moving. Upward motion we are taking. Okay, minus GT. Can you use this equation? Yes. You know the value of V. We have determined the value of U. G value is also known. So this is 0 equal to 19.6 minus 9.8 into T, which means 9.8 T is equal to 19.6, or T is equal to 19.6 divided by 9.8 equal to 2 seconds. So, for the upward motion, 2 seconds. Now, what about downward motion? Same time will be taken. Yes. So, T dash is equal to 2 times T, which is 2 into 2 seconds equal to 4 seconds. Okay. So, total time is equal to 4 seconds. Now, the third part of question, the final velocity of the ball when it strikes the ground, take G is equal to 9.8 meter per second square. So, to find this, we can take the downward motion. Okay, in the downward motion, only the downward motion is considered. Initial velocity will become equal to 0. So, it's not the upward motion, we are considering the downward motion. During the downward motion, initial velocity will become equal to 0. Acceleration due to gravity will be plus 9.8 meter per second square. Okay. Then, time taken will be 2 seconds. Total distance travelled, h will be equal to 19.6 meters. We have to find the final velocity. V is equal to U plus GT. Any of the equation we can use. V is equal to U plus GT. And V is equal to 0 plus G. 9.8 into time 2. That is 19.6 meter per second will be the final velocity when it touches the ground. When you compare, you can see the initial velocity with which the ball was thrown upwards will be same as the final velocity with which the ball touches the ground. Clear? Now let us solve questions from exercise 3E. Question 5 of exercise 3E. The weight of a body is 2 Newton. What is the mass of the body? G is taken as 10 meter per second square. This is just an approximation. So we are given weight W is equal to 2 Newton. Acceleration due to gravity. Due to gravity, G is equal to 10 meter per second square. We have to find the mass M. What is the relation? Weight is equal to mass into acceleration due to gravity. Then mass will be equal to weight divided by acceleration due to gravity. Weight is 2 Newton divided by 10 meter per second square. That is equal to 0.2 kilogram. The unit of mass is kilogram. The answer is 0.2 kilogram. Question 14 of exercise 3E. A pebble is thrown vertically upwards with a speed of 20 meter per second. How high will it be after 2 seconds? G is equal to 10 meter per second square. It is thrown upwards. Okay. What is given? Initial velocity is given. The speed is 20 meter per second. So, U is equal to 20 meter per second. Initial velocity U is equal to 20 meter per second. How high will it be after 2 seconds? Which means time is given. T is equal to 2 seconds and G is taken as 10 meter per second square. We have to find the height H. So, which relation to use? We have H is equal to ut plus half gt square. Okay, here you have to remember the body is moving upward. Force of gravity is acting downward, which means it is in the opposite direction. We have to take minus g. Okay, that is equal to initial velocity u 20 into time t 2 minus half into 10 into t square 2 square 2 into 2. Okay, 20 into 2 that is 40 minus 2 gets cancelled. 2 into 10 is 20 minus 20. Therefore, 40 minus 20 is 20. 20 meter is the height. Okay. So, after 2 seconds, the pebble will be reaching a height of 20 meters. That's all for today. In today's class, we have discussed about free fall and also we have discussed about mass and weight. We have solved questions related to it. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, purpose hai. Thank you.